aldosterone up or you're decreasing aldosterone levels. Everyone see we need to turn it down. Otherwise, we make it worse. Okay, so we're going to decrease aldosterone.
Flip everything.
Okay, therefore, we are reabsorbing. Well, I guess I'll cover that problem first. We're going to secrete.
Sodium, H2O.
Try to correct the blood pressure.
Mm-hmm.
But anything else happening?
Reabsorb potassium.
Potentially causing.
Hyperkalemia.
Are we done?
New.
What happens next?
We go over to the intercalated cells.
Um,
And
Which
be
one?
type A.
Well, what do we want to do?
We want to get rid of it.
So,
Oh,
type B.
get rid of it.
Okay. That's why, make sure on your paper you got this whole orientation down, you know, so you see we're reabsorbing, we want to get rid of it. This is getting rid of it. So we have hyperkalemia, so it will be type B to respond. Again, it excretes the potassium. But at the same time, we're reabsorbing hydrogen. Again, I just skipped the bicarbonate, but that's okay. We're reabsorbing hydrogen, potentially causing metabolic acidosis, which of course makes us think what?
Increased respiratory.
And we're done. So, we've involved, if you look at your chart there, we've involved blood pressure, we've involved potassium, we've involved pH, and we've involved respiration. Okay? If you give someone an ACE inhibitor, okay, what do you give someone an ACE inhibitor for? High blood pressure. Okay, what does it do when you memorize your chart? If you don't have ACE, you're not going to make Ang2, and therefore you're going to lower ADH and aldosterone. Okay, so we're not worried about ADH right now on this. An ACE inhibitor will cause a decrease in aldosterone. And again, the reason I like doing this is that if you look up ACE inhibitor and you look up other symptoms to look for, you see maybe something with CO2, I don't know. But you'll see hyperkalemia, metabolic acidosis. Why do you see it? Because of this. Because your cells are reacting to this. Again, it's like what we did with the reverse tachycardia thing, right? The drug corrects the problem, and that's good. But sometimes, because of the way the systems work, you have some other things you've got to deal with. Okay, hyperkalemia, metabolic acidosis, so that you've got to either do something with that or sort of correct that problem separately. But if you just have someone hyperkalemia, metabolic acidosis, maybe you know they were on ACE inhibitor, maybe you think something else is causing that, but you might have a clue on that. That's why I like doing this now, because again, it is clinically, let's say, significant, as far as the real life, and a lot of you are going into healthcare. Plus, you all might get unhealthy, okay? I like to know, when I'm unhealthy, I like to see the number report and see what it's saying, right? To make sure the doctor's not, trying to kill me or something. So, and you looked at my intercalated cells, doc. Everybody get this game.
yes.
Any other you want to do?
Yeah.
Which one haven't we done starting with? We've done respiratory, a blood pressure, a potassium. We could start off with metabolic. And then maybe it'll take a few minutes, and then I want to make sure you know how to do this other thing, as far as finding these levels. And then, then maybe a lot of people want to go or stay, whatever. But that would be the bulk of it. So let's do a metabolic. Let's vomit. Let's go to vomit.
All right.
Okay. So by vomiting, we are losing what? Okay, and so we don't have to do all that. What is that? Metabolic
Alkalosis.
alkalosis. We're losing hydrogen. Okay. What do you think? Got a branch. Got a branch.
Type A.
Because aren't there two systems in our body that will respond to it? What's one of them? What's the easy one?
Respiration.
Okay, the respiratory system is going to go. We're
Down.
holding our breath. We vomit and hold our breath. That doesn't seem like a good idea. But We lower respiration. That was the first part of the course. We're like, okay, that's easy. But when the first part of the course we said kidney responds, now we know the kidney is going to respond. Who's going to respond?
Type A or B.
Type B respond, but they respond to alkalosis. They're going to basically reabsorb hydrogen. And again, of course, secrete bicarbonate to take care of that problem. Okay, so both of these systems are working to try to take care of the alkalosis problem. So type B are responding, we're reabsorbing, but we also know we're doing what?
Secreting potassium.
So we're secreting potassium,
Hypokalemia.
causing hypokalemia. Who's going to react to that? Principal cells are going to react. We have hypokalemia, which means do we want to lose potassium or keep it? Therefore,
The ALD is going to go down.
you reverse it. Aldosterone goes down. That's how you sort of flip it. So effectively, you're reabsorbing potassium to correct that problem. But of course, we are sodium and H2O, potentially causing
Lower
low blood pressure, high urine output.
Yeah.
I don't have that kidney. The soda's up here, because the other aspect of this, since we have this, a diuretic works by keeping salt in the tubules, preventing reabsorption. You don't need to know the details that I have on that diuretic sheet, but it's interesting to know. But you have to get, we talk about, there's sort of at least 3 types of diuretics. This is my old picture here. Loop diuretics, if we don't allow the salt to be reabsorbed and the salt stays here, who follows? Water diuretic, okay? There's ones that work in the distal tubule. If we don't allow salt to be absorbed there, salt stays here, diuretic. If you inhibit the aldosterone, which is like when we're saying increasing, we're not reabsorbing salt, we are keeping it here, diuretic. Diuretics work by basically inhibiting reabsorption of salt in these last 3 segments, and by inhibiting reabsorption, we're secreting it, it's attracting the water, and that's how that's how all diuretics work, basically, overall. So you don't have to know the specific ones, Lasix and all that stuff, but you have to understand that concept of how, just like glucosuria is acting as a diuretic, so are these drugs that inhibit reabsorption, keeping salt here and keeping, in this case we actually cause the diuretic because of metabolic alkalosis. Okay? Let's take a break. Again, we just did